All right, welcome. I'm going to prove this formula for the double roots. I mean, if you want to skip this video, I wouldn't think it's that necessary to do it, but it's just for those people that want to see the proof. So let's say you have ay double prime plus by prime plus cy equals 0, okay, with a double root. So that is b squared minus 4ac equals 0. Okay, so let's take r equals negative b over 2a, and we're going to let y of t equals e to the rt. Sorry. A e to the rt plus bt e to the rt. Okay, now these are capital A's and B's. They're different than the lowercase a's and b's. Okay, in order to just basically mimic what we did in the last example. So y prime of t is r a e to the rt plus b e to the rt plus rbt. Oh, hold on, let me just make sure I did that right. Yes, rbt e to the rt. Sometimes taking derivatives is hard, I know. Okay, the struggle is real. Okay, y double prime. Are kids still saying that these days? Probably not. We all get old. It happens. So y double prime is r squared a e to the rt plus derivative of b e to the rt is rb e to the rt plus, now here we're going to have to do a product rule again. So it's going to be rb e to the rt plus r squared b t e to the rt. Okay. Move this y over here. Okay. So let's go ahead and do exactly what we were doing before. We're going to do ay double prime plus by prime plus cy equals 0. Ay double prime, you do it this way, plus by prime plus cy equals a, let me take my y double prime here, oops, plus b, let's take my y prime from here, plus c, let's take my y from here, now we want to make sure that that equals 0. We want to see that that equals 0. So we're going to do the same thing we did the other time. We're going to take the terms that have a, the terms that have b, and then the bt terms, we're going to take them all separately. Okay, and these are capitals. So let's take capital A terms first. So that equals, our capital A terms are going to be AR squared, that's this term, no more A's here, plus BR that's this term plus c times e to the rt. Okay, so now you can see again, remember, this equals 0, right? Okay, so that means that when we have our double roots, okay, AR squared plus BR plus C equals 0. So this is going to equal 0. Now let's take our B terms. Our terms that have B. Our terms that have B are going to be AR times 2, actually. Let me move that in. 2AR, right? Because we have an RB here and an RB here. I'll put the e to the RT on the end again. Here we're going to have a plus B. Okay, and then there's no terms here. Okay, now remember, look at this. R equals negative B over 2A. That's equivalent to saying 2AR equals B, or 2AR minus B equals 0. Or actually 2AR negative B plus B equals 0. That's the ticket, okay? That term equals 0. Now let's look at the T term, the term that has BT. Let's factor out a BT, and we have R squared, sorry, AR squared plus BR plus C, that's over here, e to the RT. And that equals 0 again. So all of this equals 0. Okay, you can see this. This is pretty much done on page 163 in your text. Okay, if you want to take a look again. Okay, but that's pretty much all they're doing. Okay, all right. Next, we're going to talk about imaginary and complex roots, which is another thing that could happen. Okay, we'll see you in the next video.